Today we're gonna do something different from the things I was doing in the channel. I plan to use this video to show you how to implement linked lists in Java, and then how to use linked lists to implement stacks and queues. So yeah, probably the good thing, or a good thing to start, is to say and explain to you a little bit what are linked lists and how are they used in computer science and software engineering and all other fields. And if you're looking in the internet for how to implement linked lists, you probably know already how to, or at least what they are, but it's always good to have a good refresher on what they are. So well, linked list, first of all, we have to understand that linked list contains nodes, and these nodes, they have a value attribute and a next attribute. This value stores actually the value that we want to store, and then the next is actually a pointer to the next node in the list. So of course, linked lists are linear data structures, and we have to keep track of the first variable, which in this case will be a pointer to the first node, and then we also will have to keep track of the size of the linked list. So it's probably just to go through it. This is something I just draw in a moment, and well, let me just erase this. So first of all, I'm gonna draw that again, and a linked list will keep track of the first node. So this we're gonna call the head node, and we're gonna keep track of the size of the linked list. So suppose we want to instantiate a new linked list, and when we create a linked list, we have to set the first node or the head node to null, and then initially the linked list doesn't have any value, so the size will be 0, right? So let's say we want to add a new element, a new node to this linked list. So what we do is we create a new node. So let's say we want to add the value 2 into the linked list. This is our value. This will be the pointer to the next node. And what we do is, since the linked list was empty, we just remove this connection here, and we say, well, now the head will be this one, and you point to this one, and the next of this node will go to null. And of course, we have to remember to increase the size of the linked list to 1. So what we have is, we have a pointer, or our pointer to the head node will go to the recently added node, which is 2. It has a value 2, and then its next value is null. So this is a linked list of size 1, and which has a 2 on it. Well, I think these are nice images and pictures to have in our mind for when we start implementing the methods of the linked list. So yeah, I think now it's a good time to start coding, and since I'm gonna bring up the image again, so we have this node, which will create a class for it, the class called node, and then we're gonna implement the class linked list using these nodes. So what makes sense is to start implementing the node class. So let's do this now. So we're gonna create a class called node. In this node, we're gonna use generics in Java. So this node will have a generic type T, and this will have a attribute value in next. So value has a type T value, and then it has a attribute next, which is a node with type T and next. And what do we do if we want to instantiate a node? Well, we have to create a constructor for it. So node, and we have to give it a value T and a node T next. And we say that value is equal to value is equal to V, and node next is equal to n. Well, this is all we need for the node class. If you wanted, you could implement getters and setters and use private attributes here, but I think that would only increase the the length of the video, so I'm just going to use public values, and then since I'm only going to access them in the LinkedList class, then I'm not going to worry about that too much. Okay, so well, after that we're going to implement the LinkedList since we already have the node class. Well, next thing is we're going to create a file called LinkedList.java, and in here we're going to use, and just for reference, I'm going to leave it another node.java. So I'm going to leave it here, and then I'm going to implement the LinkedList. Well, class LinkedList. This will have a generic type t. And first of all, what we want to keep track of. What are the attributes of a LinkedList? Well, it has a first attribute with points to the first node of the LinkedList, and we're also going to keep track of the size. Okay, so first of all, we have to use going to implement the attribute first. So first is a node, right? So node with the type t. We're going to call that head because it's the head of the list. And after that, we have a int size. In this, we keep track of the size of the list. Okay. So first of all, what happens when we want to create an empty linked list? Well, that's just what we had before, right? An empty linked list has a head which points to null, and the size is equal to 0. So that's what we're going to implement here. So linked list, the constructor, and head will be equal to null, and size will be equal to 0. Sure, and I'm going to lay out here some of the methods we're going to implement on this video. And well, the first methods, they're really easy. For instance, if we wanted to return the size of the linked list, we're going to have the size method, and to check if the linked list is empty, so is empty. And to get the first value of the linked list, we'll have the getFirst method. Accordingly, if we wanted to get the last value, so getLast. And if we wanted to add a node or a value to the beginning of the linked list, we'll have to have a addFirst method, and the same way we'll have a addLast. And for this video, I'm thinking about splitting this implementation in 2 videos. And in this video, we're gonna focus on implementing these methods, and on the other video, and I'm going to write it here, we're going to implement how to remove first. Well, we'll also have the remove last method, and then if we wanted to check if there's a value in the linked list, we could implement the contains method. And lastly, if we wanted to remove a certain value in the linked list, we could use the remove method. And of course, you could implement way more methods than the ones that I'm showing you here, but these are basic methods and basic functionalities of what a linked list can do. So yeah, I think it's time for us to, and we can already implement some of these. Well, the size method is really straightforward. If we wanted to return the size of the linked list, we just needed to return that variable, the attribute size, right? Well, we have to then use int, because size is int, size, and now I'm gonna use public here, int size. And all we have to do is to return size. Well, that's straightforward. And the next one is to check if it's empty. Well, this is easy too, because since you want to check if it's empty, you just have to check whether the size is equal to 0. If it's equal to 0, then it's empty. If it's not equal to 0, then it's not. Well, we have to use boolean isEmpty, and we just return the comparison is size equal to 0. Well, if it is, then it's empty, and if it's not empty. Okay, so the first method we're going to use these concepts right here is the getFirst method. So what happens if you wanted to get the first value of the linked list? Well, the first value, how do we find the first value? We have to go to the first node, and this node will have an attribute value. So essentially what I have to do is just, and since we keep track of the first node of the linked list, we just have to get the value of it. So the getFirst will return a type t, then we create a getFirst. So since we have well, I think perhaps, well, since I just call everything first instead of head, I would just change the name of the head just first. It's the same thing actually, but let's implement the getFirst. The first thing we have to do is just to return the value of the first node, right? So we just return the first node is first dot value, and that's it. To get the first node, we just have to return the value within the first node. Okay, that was also straightforward. And what about how to get the last node? Well, now it's good for us to go through an example here. Let's say we have this linked list, and if we want to get the last value of the linked list, we have to go to this node and return the value within it, right? Well, so how do we get to the last node? Now, one thing we could do is to, let me erase this. Let's say we have a linked list, we have a first, and then I have a linked list with a 1 and a pointer to another node, which is a 2, and a pointer to a 3. Yep. A pointer to a 3. This tree will point to null, to say that the linked list it's over. We got to the end of the linked list. So this is the first, as we call it, and the size here will be 3. How do we get to this node over here? Well, one approach we could use is to, well, I'm going to create a pointer. I will call it cur, and then I'll point to the first node. Okay, so this cur points to the same node we're keep tracking over here. And what we do is until the node is null, we keep traversing the linked list using the next attribute here. So until curl is different than null, then we just go, we say that curl is equal to curl.next, and then when we do this, we just erase this connection here, we can call that, and then curl will be equal to this, curl for current. And then since this is not equal to null, we can go to the other one, and then if you wanted to, for instance, get the last value, we are at the last node, and we can retrieve the value. Well, so you probably you heard me saying that if cur is different than null, but actually to get the last value, you have to say that cur.next has to be different than null. I think perhaps if we go straight to the code, I think it will make more sense. If we implement the getLast, we want to return a value t, and then getLast. Well, first thing we have to create that cur, the cur node. So it's a node type t cur. That will be equal to the first node of the linked list. Then we say while cur.next is different than null. We keep traversing the list. So cur is equal to cur.next. And right here, cur will be the last value, because the first thing we are at the first node, and then cur.next, which is this node here, is not null. Then you go to the next one. This one is not null, so you go to the next one. Now, the next of the last node, of course, will be null. And then you get out of the loop, and the cur variable will be the last node. I hope that makes sense. And then cur.value will be the value you want to return, right? So we just have to return cur.value, and then that's okay. But we're going to implement these two methods, and then we can implement the other 4 and use them to create stacks and queues in the other video. So the addFirst, we're going to be using a lot of this this conceptual image here because it makes sense. And what if we wanted to add a new node to the first of the linked list? Well, you could, let me erase all of this again. If you want to insert a new node or a new element into the linked list, let's say we have again the first, and then this points to a node, and this points to another node, which points to 0, not 0, null. Let's say this is 1 and this is 2. What happens if you want to add a new node to the beginning of this linked list? Well, first of all, we would have to create a new node. So let's say we want to add a 3, right? And this has a next. We don't know where this node is going to point. But now what we want to do is to put this in the beginning of the linked list. So what will make sense is for us to erase this connection here and put the first into the node that we want to the node I want to add, and then we say that the next of this node will go to the first the first pointer of the linked list. Okay, so again, we had the first pointing to this one, and since we want to add this at the beginning of the linked list, we just remove this connection here, and we say that first will be equal to, we will point to our newly added node, and then this node will point to the previous node, the previous first, the node which was the first at the previous linked list. So what we did here essentially was just to add the node into the beginning of the linked list, and if we were to print this out, in the beginning we had 1 and 2, and then now we have 3, 1 and 2. So we just added a value to the beginning of the linked list, and that's what we wanted. Well, so how would we implement this in code? Well, we want a public function, and since we're adding, you're not gonna do anything, we're not gonna return anything, so we just return void and then addFirst. And right here we have to pass it on a value, because we want to add this value into the linked list. Well, the first thing we need to do is to, well, create a node, just like we talked about before. We have to create a node first. So how we do that by just saying, well, I'm going to create a node, so node t, we're going to call this n, be equal to new node, and in here you have to pass the value. Well, the value is just the value you want to add, and the the pointer to the next node will be to the current first, right? So we're just gonna say first, we'll point to the first. And then what we have to do is to change the first pointer to this new node. So we say the first will be equal to n, and then we increase the size. Don't forget we have to keep track of the size variable, so we just increase the size here. Well, and for the addLast, we'll have to use again a public void addLast, and we have to pass on a value too. So now this is a little bit more tricky than before, because in this case now we want to add in the end of the linked list. So let's say we have again a first which points to a1, and this points to another node which is a 2. This one points to null. This is the first. Well, if we want to add at the end of the linked list, first we have to traverse all the list, go to the last element, create a new node. Let's say if I want to edit 3. Well, I create a new node, I erase this connection here, and I rather say that, well, this node will point to the new node that I created, and this node will point to null. So essentially what we have to do here is just create a new node. Of course I have to increase the size, right? So I create a node, go to the last node of my current linked list. I will set the next attribute to the node that I created, and this new node will point to the null object. Okay, so let's implement this in code. Well, again, I have to create a new node, so node t n will be equal to new node value again, value. Then as we saw, this new node will always point to the null object, right? It will always point to the null because it will be the last. It will be the last node. So this, instead of pointing to first, we point it to null. And all I have to do is to use that trick that we did again and just traverse the list using the cur variable, or the cur node. So node t cur will be equal to first, and while cur.next is different than null. What I do is I say that cur is equal to cur.next. And when we finish this while loop, we will be here, and we can just say that the cur.next will be equal to n, and that's pretty much it. And of course we have to add the size. So cur.next will be equal to n, and size plus plus. Now, one thing that would be really useful for us is to print this linked list. So we have to have a method that returns a string representation of the linked list, and we can do this in Java by overriding the function, the method toString. So public toString, and of course we have to return a string here. And what we'll do here is to loop through all the linked list. And for instance, in case of this linked list, if you want to display all the values in the linked list, we just use the same approach that we used before. We create a cur pointer that will point to the first one, and then we print the value of the cur, then go to the next one, print the value, and then and so on and so forth until we get to null. So we can do this by, well, just we can say that I'm going to create a string enter, and that will be equal to a square bracket, and since we keep track of the size variable, we can just do a for loop. So for I is equal to 0, I is less than size, and I plus plus. And then what we do here is just we check if I is different than size -1. Then I'm going to add the value. Answer will be the value that I want. So cur, of course I have to create the cur pointer, right? So cur, it's a node. We'll point to the first, and then we're going to concatenate the values into the answer, the string, and then I'll say cur.value plus a comma. And if this, of course we're going to do this if this is not the last position, and if it is the last position, then we just add the cur.value, and at the end we just return our string. Now of course we have to concatenate this with a closing bracket, and then we do this by like so. And let's test this. If the linked list is null, if it's empty, then size will be 0, and we're not gonna get into this for loop, and the answer will be only an opening and closing square bracket, right? And if it's not empty, then we'll go into this loop, and if the position I is different than the size -1, which is the last position, it will add a comma after the value, and at the end it will not add, so that you don't have an extra column. Not column, comma. We'll add a comma after every value, and at the end it won't, and it will just return. So right now it will be a good idea to test everything that we've done. So we can do this here. First we'll compile the program, and we'll compile both of them. First will be node.java. Let's see if we have everything correctly. Well, we do, and then after that we're going to compile the linked list. The linked list file. First we have 2 errors. Right here I changed the size to first, but I didn't change it here in the constructor. This is first, and right here there's no node class, there's only node. Then we can try this again. We'll have something here. It's probably because I didn't use the diamond notation while creating the linked list, or using the node. Yeah, right here. I have to say that this is a type T, or we can simply use diamond notation and use it like so. And we have to do this also here. Well, and now we can create a test file. So Emacs test.java, and we can test things out. So first we can create a linked list. So linked list, we'll have, let's create a linked list of integers. Integers will be L, and that will be our linked list. Of course I have to use the new keyword. Now if I wanted to add first I'm going to test everything. So L.addFirst, I want to add 1, then L.addLast, I want to add 2. That will make a linked list of 1 and 2. And then what if I want to get the first element, the first value? So I just stem.out.println. I will first print the list. Then now I'm going to print the first value, getFirst, and then the last value. So let's see what we have. Java. it's not integers, it's integer, of course. Well, I forgot something here. Of course, we have to go to the next node in the linked list, of course. So core will have to be core.next. Otherwise, we don't actually go anywhere. We just stay at the first node always. So if you do this now, and of course you have to say else. Otherwise, it's going to print things in the way that we don't want them to. So that's what we wanted. Right now, if we want to check if the list is, empty, of course we know that it's not, so we would expect a false there. And if you wanted to check, if you wanted to see what is the size of the list, we can do that too. Well, it's not empty, and the size is 2. Okay, so all the methods that we implemented, they are working. And for the next video, we're going to end up this implementation by implementing the remove first method, the remove last, the contains method, and then the remove. So that's basically it for this video. I hope you enjoyed the implementation of these first methods in the linked list, and I hope to see you in the next video.